Well, good morning, everyone. So, today we're going to look at horizontally launched projectile problems. At this point, you should have looked at vectors and had some practice with vectors, figuring out how to solve problems just related with vectors. Now we're going to use that to deal with horizontal motion. Now, here's something that's really cool. So you're going to look at this website. This is physicsclassroom.com. Great website, great resource. So one of the cool things about physics is that it allows us to do things like this. It allows us to take a look at some initial information. Like here we have a cannon. And as long as we know the initial velocity of the cannonball, and we know the position of the cannon, say the height of it, we can figure out very accurately exactly where this cannonball is going to hit. So this is for any kind of projectile, a bullet from a sniper's gun, a rocket being launched from the ground to hit, an incoming nuclear weapon from North Korea, a space shuttle launch, something being launched from the International Space Station, anything like that. So these concepts that you're learning are really pretty amazing and pretty powerful. So I'm going to ask you to read this, and then we're going to look at problem type 1, which is horizontally launched projectiles. So something just launched this way, and then it gradually falls down towards the ground. We're not going to look at these problems yet. This is problem type 2. This is where we launch a projectile at an angle. We'll look at that next class. So some equations that are really important for horizontal motion are the kinematic equations, the ones we looked at the other day. So we've got some horizontal position, initial horizontal velocity, time. That's 1/2 at squared. All right, and the acceleration here is acceleration in the x. Now, if you think about that for a second, when the object is moving in the x direction, after it leaves the gun, there's nothing speeding it up and nothing slowing it down. So, what's the acceleration? If there's nothing pushing it this way after it leaves the gun, there's nothing pushing it this way because we ignore friction. The only thing that's acting on this projectile is gravity. So there's nothing accelerating it in the horizontal direction, which means that this acceleration is actually going to be 0. So there are other equations for vertical motion. We'll get into those later. And some information on how to solve projectile problems. So here's an example problem that you can look at. Here are the given pieces of information. Talks about the unknown and goes through solving the problem. I'm going to ask you to go through this problem and copy it. All right, and then calculate the answer. So, and then there's a practice problem that you're going to do, and there'll be an answer there. And then the next thing we're going to do is we're going to do something called the projectile motion simulator, which is pretty fun. You get to simulate projectile motion and figure out what's going on. We're going to follow that up next class with something called turd the target, where you're a bird and you try and drop poop in a bucket as you're flying horizontally, which is kind of cute, kooky, fun. So that's what's going on. Let's click on the projectile motion simulators just so you can see what it looks like. So we've got activity 1, which is projectile motion. And there's a little handout that's going to be right here. And I'm going to ask you to answer the questions and figure out what happens. Okay, so we'll do that. And then we'll go back to activity 2 and the horizontally launched projectiles and go from there. Okay. So this will be what you'll be working on today and for homework. The simulator itself is right here. So if you click on Launch Interactive, it'll pop up. And let me just show you how to use it. So let's say you want an initial speed of, say, 10 meters per second. There we go. And let's say you want to start at a height of 21 meters. You want a 0-degree angle, right? Because flat. So let's go. Let's hit start. There it goes. All right. So it just kind of curved and went down. You can even click on Show Velocity Vectors and it'll show what those were at any moment. I can now reset it. Oh, I made it larger. That's better. I can reset it, and I can start again, and there it goes. If I want to start with a better height, let's give it some more height. This will be more fun. A little more speed. You can even trace the path. Alright, you can see the initial velocity, just because I bumped up the speed here, the initial velocity vector is getting a little longer, right? So let's see what happens. Here we go, 1, 2, 3, boom. Look at that. Why is that getting larger? It's falling faster because gravity's always pulling it down. So, we can even click on the acceleration vector and notice that it's just straight down. So this is what you're going to be playing with. There's a bunch of questions you're going to be answering. You've got time up there. That's a piece of information you can use to solve some problems, and you can put in your initial information there. We've got X and Y displacement. So these are your X and Y components here and here, right? Your Y is now 0. It was 95. Your X, you went 215.76 meters that way because this was 0. So there you go. Hopefully that all makes sense, and good luck.